Today we're going to talk about sets and Venn diagrams. So let's start with a couple of terms. A set, is this first word, is considered to be a collection of objects. The members of the set are the objects within it. We write sets by listing out the things inside using the curly braces. And then we indicate that if we've got a pattern of things, so if we've got a long list of things, once we establish the pattern, then we just use the three dots to indicate that there's more to it, but you've seen enough to establish the pattern. And then that brings us to, well, what kind of graphical representation are we going to use? And this is what's called a Venn diagram. In a Venn diagram, we use circles to indicate certain information that's collected or gathered up. Okay, so let's take a look at some examples of writing out sets. So the set of countries larger in land area than the United States. Turns out there's not that many out there. So we'll do little curlies. For example, just thinking about it, Russia and Canada would be the two ones that I can think of. So Russia and Canada would be our set of objects, countries larger than the U.S. The set of natural numbers greater than 5. So natural numbers would be the counting numbers, like whole numbers, whole counting numbers. So things like, let's see, bigger than 5 would be 6, and then 7, and then 8. And then, hopefully we get the pattern. So I would use the three dots to indicate that the pattern just simply continues. Okay, so let's talk about some particular types of sets that one might encounter, and then look at some images of these things. So first was something called a subset. Subset. So if A is a subset of B, then all the members of A are in B. So we use a box to represent a universal set. This is the big set, which we're going to call B. And inside B is a little set A. So when we say A is a subset of B, we're saying everything in A is also in B. Then we have an idea called disjoint. Okay, so if A is disjoint from B, then they have no members in common. So if I look at sort of the population here, here's set A, and here's set B, and there is no overlap. There's nothing in common between the two. And then the third category that one might encounter is something called an overlapping set. Overlapping is when there are some commonalities between the two. So there's sort of this overlap between them. Okay, so we're going to use Venn diagrams then to illustrate these different types of sets. So we say that whales are a subset of mammals. So that means if I draw a big picture and I have a set of mammals, inside mammals are whales. Would be what that image looks like. The set of fish is disjoint from the set mammals. So you can either be a fish or a mammal, you can't be both. So that means I'd have one set that's mammals, and I'd have one set that's fish. And then the third set would be the set of doctors and women. So that means I've got one set that are for doctors And there's another set that are just for women. But it turns out I'm lucky enough to have women doctors. So there we go. Okay, so describe the relationship between Democrats and Republicans and draw a Venn diagram showing this relationship. Interpret all the regions of the Venn diagram. Okay, so we're going to, part of this is you have to know a little bit about politics to kind of understand what's going on here. So I'm going to start with the set of voters out there. And we're going to focus in on the two sets. So either people are Democrats, or it's not really anyone that could be both of those, or Republican. So what about this in the middle region? So either you're a Democrat, Republican, or you're a third something, and we actually call these independents, would be how to interpret that. So you got to be either the Democrat set, the Republican set, or not in either set. Okay, draw a Venn diagram showing the relationship between natural numbers, whole numbers, integers, rational numbers, and reals. Okay, so I'm going to need a big picture. Okay, so inside this big picture, we're going to start with the smallest thing that we can think of, which are what we call the natural numbers. Okay, so natural numbers, when you're first born and you're getting taught how to count, you look at your hand and you count with your fingers. Those are the natural things. So it's natural to count with those things. After natural numbers, we encounter something called whole numbers. Whole numbers are, oddly enough, we throw 0 in there. That makes it whole. It's just somebody realized that we had to be able to count. What if there's none of something? We have to have a way to describe that. That's where whole numbers come in. And then after whole numbers, we encounter integers. Integers are now negative counting numbers, positive counting numbers, and 0 are included. Then after integers, we discovered fractions, which we call rationals. And let's see, what am I missing? I got rationals and then real numbers. So real numbers, be careful with my little circle here. Let's see, that's rational. We'll go real. Okay, so things that aren't rational will then count to be underneath the umbrella of real numbers, which means there are real numbers that aren't rationals. Well, those are actually called irrationals. And just for kicks and giggles, it's not on the chart, but if we go outside of reals, we get something called complex. You might have seen complex dealing with I, or imaginary numbers. Okay, so let's add some more vocabulary to our understanding of this idea of prepositions. So we're going to branch out to something called a categorical preposition. And a categorical preposition are sentences, or have the structure of a complete sentence where we're talking about sets. There's at least one set in the subject of the sentence, and what we consider to be the conclusion, going back to if P, we're actually going to call the predicate. So we have a subject set and a predicate set. So let me write this out here. We got subject and predicate. Okay, so kind of like we would consider to be P, Q, if, then sorts of things. But with sets, we're not looking at the truth value or the conditionalness of the statement. We're just looking at whether one set is connected to another set, or if they're, there's different Venn diagrams that we looked at. Okay. So the statement all whales are mammals, the statement whales we define as to be the subject set, and mammals would be our predicate set. Okay, and we've actually seen illustration of this one with subset. So we have the mammal set, and then inside we have the whale set. Okay, so no fish are mammals. So that means no fish would be the subject set. And again, mammals in this case would be the predicate set. And we've seen this via Venn diagram as well. So we have the set of fish, we have the set of mammals, and there is no overlap between them. These are disjoint sets. Okay, then we have, let's see, some doctors are women. So some doctors would be our subject set. And women would be our predicate set. And this is the one we looked at that was overlapping. So we had doctors and we had women, and then there was some overlapping between the two categories. Okay, but what about some teachers are not men? Okay, so some teachers would be our subject set. And not men would be our predicate. Okay, so let's kind of think about what that means. We have a set of teachers, and is it safe to say that there are evidence in front of you? Are there some teachers that are men? So there's got to be an overlap between the two. So where would we find a person who's a teacher but not a man? And that would be in this little category in our picture.